So guys, we have received this cable from Asus. I'm sorry, I have it for quite some time now. I think 3 months, 4 months. But unfortunately, I didn't have the time to test it. I think that after many reviews came out, it's time for me to make a proper test of this cable. As a workhorse, I will use this PSU. Okay, Corsair. These are some of my cables that I made. The prototypes, the final. This cable includes PCB, so all the logic is inside the cable. Now we see newer generation power supplies from Corsair, from MSI, which include an OCP per pin on the 12V 2x6 connector. So this is not needed anymore since it is included inside the power supply. But in previous generation power supplies or in power supplies that don't have OCP per pin, you could use such a cable. That's another option. This cable doesn't use any active components, it doesn't have any logic. The only thing is here. This metallic part here actually hides a bridge. What is now the whole philosophy behind this cable? This bridge short circuits all power gauges, all power wires. So even if a cable is cut, you have this bridge which makes loads equal. So from here to here, all wires, all cables will have equal load. Even if you somehow damage one of the power cables. This means that the pins will have equal load as well, and typically, usually, the pins are the ones that melt first and create all issues with melted connectors and all this stuff. And this is why also the bridge exists in this side, in the GPU side, and not on the PSU side. Among the thousands PSUs that I have in the lab, I took the only PSU that doesn't have a native 12V 2x6, but it had two 8-pin instead. But for this testing, I need a native connector. It helps. Okay, good. A super flower PSU, high quality power supply. Lead X3, one of the best PSUs in its category. Okay. Okay. Now this is some extra sense cable, I won't use that because this is only for Asus PSUs, but anyway. I hope it works. So let's start the PSU. Fan started, PSU runs. Okay. Just to make be sure what cables I will. So the 12V line is on the same side with the sense. Let's see if that's correct. Yeah, it's correct. So the power cables, the ones that matter to us, are these ones. And on the top side, they are the return F cables. We don't care about that. We care about the power cables. To distinguish them, I've wrapped all together, and I know that these are my power cables, okay? So, let me connect now the PSU. Okay. Let's put it here. Okay. That will make some noise. I also want that. Monitor the temperature, guys. Just put that here. So the idea is to put a sensor here to check the temperature. Yeah, it's not that easy. Okay. I have this shit. Okay. Eddie, I want a good video because this is the first and only time that I will do it, okay? I will destroy the cable. So guys, I'm connecting a thermistor here to watch the temperature. I don't need voltage multimeter anymore. So let's start. Λοιπόν, 600 watt, 52 amps. Way too high amps. Why? Because I have huge voltage drops. This load has a remote sense, but I haven't connected it. So, okay. The thing is, the cable is hugely overstressed right now. Okay. What we will do? Leave it for a bit. We'll watch the temperature here. The temperature is normal. Let me see. You see the temperature starts to increase. It's normal. 52 amps pass through the cable. All 6 gauges are in now, the power gauges. So, because I don't have much of the time and I need to go out do some stuff, what I'm gonna start doing? I'm gonna start cutting wires. Let's start cutting wires. A good part.
Maybe.
5 gauges. Thomas, come here. Come to be in the video, man. Come here. Thomas is the engineer, cybernetics, part analysis. So, one cable off. They start to get hot. I can feel it. They start to get hot, guys. Second cable off. Now we have 4 gauges.
Why are you doing this?
The idea is to have the more amperes passing through the less amount of cable.
Yeah, but why?
Because if you have many cables, the load distributes to these cables. When you have less cables, the load has to pass through fewer cables, so amps are more per cable. And amperage, higher amperage means high temperatures. So,
Yeah, but what can be the scenario that this happens?
it will melt. And
No.
normal connected will melt.
I mean, when are these cables gonna be cut in a normal scenario?
You don't cut them, but in some cases the connector might not be fully connected, and so some of the wires don't make perfect contact. So we simulate that. Actually, we simulate it in the worst possible case. So, third cable cut. That's the most important. That is steady, 52 amps, okay. Guys, third cable cut. Let's see. This is a heatsink also, that's why it's metallic, I think. It actually works. Did you expect it to work? No. Okay. Another 4, now all the load, 52 amps, pass through only 2 gauges. Up to here. So you have 26 amps per gauge. Wow. Okay. Well, temperature is okay. It's not that bad. Yeah. We will leave it for 5 minutes, but temperature is okay. Guys, look all the cables that I cut. This get hot. If you have your hand here, this get hot because they are connected to the bridge. Yeah. You can feel that they're hot, although the insulation. So the idea is that up to here, to the bridge, only 2 cables come. Yes, but here, all 6 cables are connected again because of the bridge. So the pins don't get 26 amps each. The load is equally distributed to the pins. This is the main idea behind this design. 5th cable cut. Only one wire will handle 52 amps. Let's do that. Yeah. Look how low the voltage is dropped. Yeah. Okay. Where's the single wire? Here it is. Wow, it's hot. It's hot, but the pin won't melt. If something melts, it will be the wire itself. The pin, it might melt from the PSU though. Yeah, we'll have to be. Oh wow,
Yeah.
it's hot. Yeah, you cannot touch it. Yeah. Let me see. Yeah, it might melt from the PSU because the pin here has 52 amps. A single pin. Yeah. Normally they should have the bridge. Oh wow. Oh. Normally they should have the bridge on both sides. But look, the connector on the GPU side, and the GPU is the most expensive. It's okay.
Yeah.
But on the PSU, guys, I expect that to melt soon.
Mhm.
I can do something else. Now I have to find. Look, 122 degrees, 125. What the fuck? Look, I told you, it's hot. It will melt. It's a matter, guys. It's a matter of minutes to melt. Wow, it melted the thermistor. What the fuck? The thermistor, the insulation of the thermistor melted. Okay, doesn't make any sense to break the PSU, guys. Okay, I stopped the load. Look how fast though. 130. A single cable was handling 52 amps. A single gauge, sorry, not cable, a single wire. So, to wrap it up, okay? And Thomas, if you want to intervene, just feel free. The system works, but this system right here protects your GPU. Okay, yes, the GPU is the most expensive part. As you can see, the temperatures on this side were very low. Okay. Sure. Okay. The temperatures on this side were very low, but guys, if you have an issue on the PSU side, the temperatures were off charts. Guys, it melted. Look, it melted.
Yeah.
And this thermistor, guys, can take up to 200-300 Celsius. And it melted. You try to remove. Be careful, it will be very hot, huh?
It's not a fan anymore, but it's hard to remove it, so probably.
Hey, we didn't leave it for long, Tom. It melted.
Just isolation.
Yeah, it melted. On this side, it melted. It melted. What the... Why? My question, and if you have any ideas, Thomas, why they didn't install the same bridge on this side too, to provide full protection? Why did they install the bridge only to one side? That's not the optimal design. They should install the bridge on both sides. Because you see now, the GPU side is safe, the PSU side melted. So what's the point? What's the point?
Just to cut the expenses.
Just to cut the expenses. Yeah, but I get it.
It doesn't do the job.
Man, I get it that the GPU is the most expensive. But imagine if you have a $1,000 or euro PSU connected, and it melts your pin. The PSU is for nothing then.
The bridge may do the job on the other side as well.
The bridge is cheap, Thomas. Why they didn't install the bridge? Thomas, do you want to take that to open the bridge to show to the people what is actually inside? Okay, take it, man. If you can open it a little bit just to show to the people what's inside the bridge. It's basically a copper bridge, but yeah, I think you can remove it easily. This stuff. Guys, the system works, okay, and we showed to you that it works, but it works on the GPU side. For me, the cable is fine, it's good, but it needs to have two bridges. The same system on both sides, not only on the GPU side. Else, yes, if there's an issue, you will save your GPU, but I showed to you that the connector will melt from the PSU side, and most likely it will also damage the PSU itself. So the ideal solution is this cable with bridges on both sides. This is my opinion, at least, and you can form your own opinion after all this stuff that we showed you here. Now, given that the new trend in power supplies is to include this system that I made, OCP per pin, this now is inside the PSU. You don't need, I think that you don't need an expensive cable. If this cable is sold for $10, say, okay, it's an extra protection feature, go get it. If it is too much expensive and you already have a PSU, like a modern Corsair or Asus, CWD made a very good system. Or MSI PSU, then you can rely on the PSU's own protection features. And from now on, also in my PSU reviews on the tables, on the protection features table, I will include OCP per pin for the 16-pin connector. This will be a new addition. When we have upgrades, guys, I have to also upgrade my methodology, and this is one of these times that I have to do it. Thomas, thanks, man. Guys, that's the idea. That's the idea. That's the bridge I was telling you about. All cables are connected here. So even if you cut these cables from here to here, the load will still remain equally distributed. So you won't have any problems with the pins like I had on the PSU side. It's a very plain, very simple idea. But guys, the simple ideas are the ones usually that work the best and without any issues in the long run. If only they install this system also on this side. If only. It will be full protection. So, that was all. Thomas, PSU engineer, part analysis engineer in cybernetics. Aris, Eddie behind the camera. Thank you. See you next week.